Good morning and welcome back to section 7. We're going to be looking at curve fitting with linear models, with lines. And curve fitting is something that we're going to be doing a lot of this year. We'll be doing with lines in this chapter. We'll be doing it with quadratics in chapter 5, polynomials in chapter 6, exponential and logarithmic functions in chapter 7, and we'll be continuously doing this throughout the school year. And this is where we're going to take data and we're going to make a model based on that data. And so we'll start it now. We'll see it now. Lines are kind of boring, but that's okay. The process is the same. So, looking at our learning targets for today, I can fit scatter plot data using linear models with and without technology. The with technology is probably going to be a little bit new. And I can use linear models to make predictions. So, modeling by hand. This is probably what you've done in the past. First, we need a data set. So here we have Lincoln High website and days, first 2 weeks, and the number of hits that website got. So it's just a bunch of data. We can graph this data. We would graph this data on a scatter plot. A scatter plot, you just graph the points. That's all it is. It's a bunch of points scattered around a plot, hence scatter plot. And so we get our plot, and we graph the points. We're going to have 1, 5, 2, 10, 3, 21, 4, 24, etc. And so we can put these onto our plot. And looking at it, does it look linear? Well, it's kind of linear. It's got a couple low points here, but it's going up in a somewhat linear fashion. So the next thing we're going to do is we're going to draw a line of best fit. Now, when you draw a line of best fit, this is an estimate. We're going to see about where is the line that's going to match this data. It is not in a perfectly straight line. Real data won't be perfect, and that's okay. The model gets rid of the little inconsistencies, and it gets us an estimate for what we think it should be about. And so if we drew a line up through these points, that would be too high because it wouldn't get these. And through these, that would be too low. I'd say let's put a line kind of right in the middle, a little bit more towards the top, right about there. That looks like a line that might represent this data. And so from here, we can make an equation for a line. We just need to find a couple points. I would choose a couple points that are close to easy points on the graph, like the point 8, 30 looks like it hits the graph pretty much dead on. And same with the point 2, 10. That might be 2, 11, but it's close. From here, we can find the slope, 30 minus 10 over 8 minus 2. I chose to do the bigger numbers first just to keep it positive. Subtract 20 over 6, and so our slope is 10 over 3. And so from here, we can put it into slope-intercept form. We have our slope. We actually have a y-intercept on our graph. Looks like it's hitting at about 5. Could we put it in point slope form to find that? Maybe it's not exactly 5. We could, but honestly, the line of best fit is an estimate as already. And so taking this estimate, doing a whole bunch of really precise calculations based on a guess seems kind of silly to me. So use 5. So y equals 10/3 x plus 5. And then from here we can answer questions if we need to, but that would be the equation of the line. We'll see how to do this in a calculator later, which is going to give us a much more precise line. But first, we need to talk about correlation and the correlation coefficient. Correlation is simply how close to a line is the data. Is it really close to linear? Is it really spread out? The variable for correlation is R. Obviously, correlation, what doesn't scream R about that? R is always going to be between -1 and +1, where when it's bigger than 0, there's a general upwards trend, And when it equals 1, it is a perfectly straight line. There's no deviation from the line. It's like you had an equation, you plugged in points, you graphed the points. When r is less than 0, there's a general downward trend. And again, when r equals -1, it is a perfectly straight line, just with a negative slope. And then the closer to 1 or -1 is, the closer to a line the points are. When it's closer to 0, that's where there's no correlation. Although it could be a perfectly straight line that's just horizontal, because that's not going up or down. So some examples of some correlations. So here's another correlation of 0. It's just spread out. We can't tell if it's going up or down. If your points come back in a quadratic, even if it's perfectly, like if you took x squared and you plugged in points for that, the correlation is 0, as long as you were symmetric about the vertex, because that's not linear. So here is a positive correlation, about 0.5. We can see that the points are generally going up, and here it's a lot closer, 0.9. It is going up. Here's a slight negative one. Here's more negative. See how they're closer than this one? You can tell they're going down a bit more. And then here, negative 0.99. This is really close to a line. But even still, there's a bunch of variation there. But drawing a line of best fit here would be easy. And so that's the correlation. We're going to be finding the correlation. There's an equation for it that is unpleasant, to say the least, and very, very difficult to use if you have more than like 3 or 4 points. It becomes a bit overwhelming, and it even uses things like standard deviation that we haven't learned about yet. So we'll see how to find that on the calculator. And so speaking of calculators, let's look at this. Let's model with the calculator. And this uses a process called regression. So we're going to use the same data set so that we can compare our line of best fit with the calculator model. And speaking of calculators, I'm using the TI-84 Plus. It's a color one. I use this for a couple of reasons. One, it's basically the same as we have in class. The class, it's the next generation one, but it's done the same. And it's also one that a lot of people have. But this is also the one that I have on my computer that I can use. And so there we go. And so the first thing we're going to do is we're going to make sure that the diagnostics are turned on. So to do that, we can go to Mode and scroll down to Stat Wizard. It's on. If you have, or Stat Diagnostics is on. If you have an older one, you'll need to go to the Catalog, which is second 0, scroll down to Diagnostics on, which you can hit the D button, and then just scroll down. Once you find Diagnostic on, you can hit the Enter button twice. Once to select it and once to run it. And we'll see what that does in a few minutes. So now, step 1, we need to enter the data. For that, we go to Stat, and the first one is Edit. Hey, look, I have a list in here. I need to clear it. So to clear it, we're going to go up and clear, and then go down, and that'll clear my list. And now you can enter your data. And you do that just like you're just making the table. So 1, 2, you can use the down button, you can use the enter button. I'm going to use my keyboard because it does it a lot faster. But we are entering the data. It takes a little bit of time. If I'm going faster than you are, which you should be following along here, if you have your own calculator, feel free to pause to get your data entered. So I entered the day list for X for list 1, and then the hits in list 2. When I was entering this, I was looking at a very small thing, and I had to look at the numbers. Almost done. Entering your data accurately is very important because if you put the wrong numbers in, it will mess up everything that you're doing. All right, so now that we've entered the data, we're going to graph the data. For that, you're going to go second and then y equals to get to stat plot. I quit out of that first. You don't have to, but it's not a bad habit. But second, y equals to get to stat plot, and you're going to select one of the plots, probably the first one, and turn it on. There's a few type of plots here to select. The first one's a scatter plot. The second one is a scatter plot that's connected, then a histogram, box whisker plots, and then normal probability plot. When you select that, notice it has two lists to choose from, probably list 1 and list 2. The mark is your option. The color is your option. If it's not list 1, list 2, you can get to the lists by second, and then the list number will get you the lists. And then if we hit graph, it's going to take us to a weird thing. So let's zoom, and number 9 is zoom stat. So that'll zoom it to the data that we're looking at instead of whatever the previous zoom window is. And so we can see our data. And that looks like our graph that we made. Step 3, we're going to do the regression. And so for that, you go back into stat and go over to calc. And we're going to choose number 4. It's linear regression, ax plus b. That would be linear. 8 is another one that would work too. It just switches your slope and y-intercept. We'll use the other ones throughout the year. Then we need to set it up. List 1, list 2. For the stored regression equation, we want to put in y1. To get to y1, we do alpha, trace, and it pulls up this window and it's y1. If you have an older calculator, we can get to it too. It's different. Then we can calculate. And look, there's our equation. It gives it to us like this. We have y equals ax plus b, and a equals 2.4, blah, 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 b equals 11.2, blah, blah, blah. Then r squared and r. Hey, the r is the correlation coefficient. That's what we were just finding, or talking about in the previous slide. If you didn't do the diagnostic, those wouldn't be there. Having the y1 puts the equation into y1. If you can't find y1, you can just type it in. Then step 4, we graph, and you just hit the graph button. Everything's set up. So we check the graph. And then finally, answer the question. I haven't asked a question yet, but how would you expect on day 50? So you can type it, you can plug in 50 to your equation, or go to y1 parentheses 50. This is function notation. That's y1 of 50. It'll plug 50 in for you. Enter, and we'd expect 131.6.7 hits. Obviously, we're not going to get a piece of a hit, but we'd expect about 131 hits. And then another question is, how sure are you of your answer? In this case, I wouldn't be particularly confident in my answer. Partly because, it was kind of linear, but it was also it wasn't, like, the correlation wasn't very high. But secondly, we plugged in 50 for day 50. Well, our data only goes up to day 14. A lot can happen in those next days. Like, if I were to plug in, like, what is the prediction for day 15 or 16 or 17, I'd be a lot more confident in that prediction. Plug it in for something way out there is called speculation. You want to be wary of that. But based on our model, this is what we would expect. And so that would be modeling with a calculator. When we're doing this, the steps are the same no matter what type of modeling we're doing. With quadratic, everything is the same. We enter the data, graph the data, do the regression, check the graph, then answer the question. The difference is we would pick a different regression in this step. That is the only difference between different types of regression. If you have a different type of calculator or computer program, how you do each step might be different. Like, there might not be a stat button and edit. You'd enter your data differently, but you're still going to enter your data, graph your data, do the regression, check your graph, and then answer your question. If you have one of the older calculators and the alpha trace didn't get you the y1, you can go to the vars menu, and the first one is going to be yvars and function, and then y1 will be in there. So this is modeling. We have without a calculator, we have with a calculator, finding the regression, which happens automatically as long as the diagnostics are turned on. And that's about it. So again, we'll be doing this quite a bit throughout the year, and you'll become a lot more comfortable with it. But don't be afraid to rewatch the steps, because this is a process. It's not just like a formula or something. So happy calculating, and I'll see you next time.